Okay, for this problem is the uniform beam has a weight of 300 kilonewton. If it is initially placed while being supported by two cables at A and B, the problem would like to find the tension in the cable A if cable B suddenly fails. We assume that the beam shape is like a cylinder log and the beam length L is 10 meters. Okay, so for this case, we starting with consider the log. Okay, we starting with consider the log, and we found that when the cable B is failed, so it should have the rotation about point A. So then we have to determine the mass moment of inertia of the beam about point A. That is, for this case, we just use the formula that we already know. That is, we have the mass moment of inertia of the log at the center of gravity. This is equal to 1/12 ml squared. But now we have to use parallel axis theorem to transfer to determine the mass moment of inertia about point A. Okay, so then this is we have IA equal to IG plus MB squared. Okay, and we determine IA that is equal to this box. After that, we draw the free body diagram and kinetic diagram. Free body diagram is on the left hand side, and kinetic diagram is on the right. Okay, for free body diagram, because the cable B is cut. Okay, so we have the cable A, generally cable A that is has the tension at point A, and it has the gravity at point G at the middle of the beam. And for the kinematic, for the kinetic diagram, that we have the beam should be goes down, and we have MA, AG should be go down, and it just has the rotation also. Okay, and has the angular acceleration should be alpha. Okay, so according to this, according to this picture, we can derive the equation of motion like this. That is, we consider summation Fy equal to MAY. Okay, and we set downward at a positive because we set up follow the kinematics. Okay, kinematics, the beam is just tend to go down, so then downward should be positive one. Okay, that means that on the right hand side we keep it in terms of the positive. Okay, so after this we have the first equation. Okay, and then we consider the moment. Okay, we take a moment about point A that is equal to IA alpha. Okay, so the moment on the left hand side we consider from the free body diagram, and we found out the moment about point A is equal to mg times L over 4. And on the right hand side it has we have IA alpha. Okay, IA alpha, that is IA we already determined, that is come from the parallel axis theorem. After that we substitute any value from the problem, and we solve for the alpha first from the second equation. We obtain that alpha is become 1.68 radian per sec squared. And after that we substitute back alpha into the first equation. To the first equation, we found that AG is equal to alpha times R, that is now R is L over 4. And after that, we can complete for the tension TA, that is equal to 171.4 kilonewton. Okay, you see that according to the dynamic problem, you see that the tension is increased from the static. Okay, if we consider the static, we found that the tension it should be just only 150. Okay, so then for this case, it's increased from 150 to 171. Okay, it's maybe about 50 to 10% around that. Okay, that's complete this problem.